I welcome you all for this session. In this session, we will continue the discussion on linear measuring instruments. We will discuss about the dial indicators, dial test indicators, digital indicators, digital and dial thickness indicators, digital depth gauge and universal caliper. Now, first let us discuss about dial indicators. This figure shows a commonly used dial indicator. I can see the various parts of the dial indicator. This is the bezel and bezel lock, and this is the dial. We have a bigger dial and a smaller dial. The resolution of this dial is 0.01 millimeter, and for each revolution of the big pointer, this small pointer will move by one digit, one graduation. So, the range of this measuring instrument is 0 to 5 millimeter with resolution of 0.01 millimeter. Now, there are limit hands. We can set these limit hands for upper and lower limit of the to set the tolerances. Whenever the pointer goes beyond the limits, then the workpiece can be rejected. So, this can be used for limit gauging purpose, for comparing the dimension of the workpiece with the nominal value. And this is the stem and plunger, and this is a carbide contact point. Most of the parts are made out of high strength stainless steel, so that it will be rigid and it will be sturdy. Now, what are the specifications of dial indicators? Now, these dial indicators are available to work in normal working condition as well as in the condition where there is splash of coolants. So, waterproof type are also available, and back plunger type are also available. In some cases, we have to use the dial indicator wherein the plunger is at the back, and then long stroke dial indicators are available with the range of 0 to 300 millimeter, and the dial size can be 31 to 36 mm for a very compact dial indicator. Where space is not available, such compact dial type indicators can be used, and large diameter dial also they are also available with 92 millimeter diameter for easy reading. Now, you can see the graduations are available in 0.01 mm, 0.001 mm with the range of 10 millimeter, 5 millimeter, 1 millimeter, like that, and in bracket we have indicated range per revolution. So, per revolution is the range is 1 millimeter, and then accuracy of these dial indicators, the overall accuracy is about 13 microns for this particular range, and if for 0.001 graduation, the overall accuracy will be 5 micrometer, and repeatability will be like 0.5 micrometer, 3 micrometer. So, depending upon our requirement, we have to select the appropriate dial indicator. Now, there are different types of contact point. Plunger ends are available like ball point end, shell point, spherical point, conical point, knife edge. So, depending upon the application, we have to select the proper contact point. For example, say we have a very narrow groove like this. So, we have narrow groove like this. In such cases, we may have to go for knife edge type, so that it will enter into the groove comfortably. So, similarly, the spherical type, say the contact point will be like this with larger radius, and when the work pieces are pushed from the sideways, then such spherical type of indicators will be very useful. Also there are lever type indicators which we will be discussing after some time. Then let us see the construction of the dial indicator. I can see this is the measuring spindle or plunger. There are built-in rack in the spindle, and we can also see the pinion. So, when the plunger moves, this pinion will also move, and there is a set of gear train. This pinion is fixed to the bigger gear, and this is in contact in mesh with another smaller pin. Like this, there is a train of gears. So, the displacement gets amplified. So, now see this dial indicator, one thing is it senses very small distances of the order of maybe 0.001 millimeter or 0.01 millimeter, very small displacement which we cannot sense. So, this type of dial indicator, it senses the very small displacements as well as it amplifies, like for example 100 times, 200 times, 300 times it amplifies, and finally at the pointer, depending upon the pointer length also we get some magnification. So, in the dial we can comfortably note down the reading. For example, if the plunger moves by 0.01 millimeter, the pointer will move by approximately 1.5 to 2 millimeters. So, finally, we get a magnification of 100 or 200 times, so that we can comfortably record the displacements. Now, we have a spring here. So, when the workpiece is removed, the measuring spindle will come down because of this spring force. We can also see there is a hair spring for balancing purpose. Now, we have another dial indicator. This measuring range is 0 to 1 millimeter, and the resolution is 0.002 millimeter. So, for one complete revolution, we can see here it is 0 to 100 and again 0 to 100. So, for one complete revolution, the smaller pointer will move by, it will indicate 0.2 millimeter displacement. Now, this is the we can see the mounting arrangement here. At the back we have a hole is available. So, using this we can fix this dial indicator to the magnetic stand, and we can do the necessary work. Now, this shows dial indicator with magnetic stand. We can see the magnetic stand, and we can also see how the dial indicator is fixed to the magnetic stand. Now, I will explain how to use the dial indicator for comparing the sizes of the workpiece. That means, the dial indicator is used as a comparator. Now, this is the dial indicator, dial of the dial indicator, and then this is the stem. So, this stem is used for fixing the dial indicator to the stand. Now, this is the plunger, and this is the carbide tip of the plunger or spindle. Now, this is the stand of dial indicator, and this is the reference surface datum. And now, initially we should know what is the approximate thickness of the workpiece, and then we have to set the dial indicator. For that, the approximate size of the workpiece is 10 millimeter, and I am taking a slip gauge of 10 millimeter. You can see the slip gauge. This is a 10 millimeter slip gauge. I am putting it on the datum surface after cleaning, and then now I have to set the dial to read 0. Now, it is reading 0. I will just lift the spindle, I will remove the slip gauge, and then I will put the workpiece, the thickness of whose thickness of this workpiece is to be measured. I am keeping that on the datum surface. Now, I have to take the reading. So, now when we lift the spindle, it moves in the clockwise direction. Okay. So, now when we keep this workpiece, now the dial indicator reading is, the resolution is 0.01 mm. So, the dial indicator reading is 0.2, 0.4, 0.5, 0.588 or 0.59. So, the size of the workpiece is 0.59 millimeter greater than the slip gauge setting. That means, slip gauge setting is 10 millimeter and size of the workpiece is greater by an amount of 0.59 millimeter. So, the thickness of this workpiece is 10.59 millimeter. So, like this we can use dial indicators as comparators. For direct quantitative measurement within the range, for example, dial indicator is having 0 to 10 millimeter, within that range we can use this instrument for direct measurement. So, we can keep the workpieces below the plunger and between plunger and the datum surface. The plunger will move up and it directly gives the reading, whether it is 2 millimeter or 5 millimeter or 8 millimeter. Now, what are the various applications of dial indicators? So, we discussed about this. It can be used for comparison purpose, comparison of workpieces with the set level, and then this can be used for setting fixtures. Say we want to set jigs and fixtures on the machine. So, whether it is properly fixed or not, whether it is properly aligned or not, for checking that we can use this, and also for acceptance tests on various kinds of machine tools. For example, say we want to check whether the slides, various slides like tailstock, quill and saddles, whether they are parallel, whether they have parallel movement with respect to axis or not, or if there is error, what is the amount of error, and if there is run out of the spindle of lathe, so we can check using the dial indicator. So, for alignment testing we can use this dial indicator. Also for backlash checking we can use dial indicators, and also for direct measurement this can be used. Now, we will move to dial test indicator with universal swivel. This is also known as lever type dial indicator. We can see we have a dial here with the pointer. We can have we can see the graduations. In this case graduations resolution is 0.01 mm, and this is the lever of this indicator. This can be used for alignment purpose or setting purpose, or for comparison purpose. So, one arrangement is shown here. The slip gauge of required height is used for initial setting. This is set to 0, for example 40 millimeter slip we have kept, and reading is adjusted to 0, and then we have to remove this and workpieces can be inserted and then readings can be. In that case, the height gauge scale will not be using, only we will be reading the dial test indicator readings. Now, this shows the another view of the dial test indicator. This is the carbide tipped stylus. Now, we can see here we have the working mechanism of dial test indicator. This is the lever which will move like this. So, this will move to approximately some 30 degrees. It can be set at any angle, and then it will swivel like this. That is why it is known as universal swivel dial indicator. And then this is the this lever is attached to the gear sector, and then this is in mesh with pinion. So, when the lever moves like this, tilts like this gear sector will move and then pinion will rotate. So, this pinion is fixed to the crown gear pair. So, this smaller crown gear will rotate like this, and which is fixed to the pointer, and pointer will move on the dial and we can take the reading. So, this is the working mechanism of dial test indicator, and you can also see there is a bumper bumper made out of rubber. In case it moves beyond the limit, so this lever will come and hit the rubber bumper, and it will prevent the damage to the internal mechanism. Now, when we use these dial test indicators, the angle between the workpiece surface and the lever plays a major role. We should always see we should always try to minimize the angle between the lever and the workpiece surface, otherwise the cosine errors will happen. So, that can be seen like this. We have the workpiece surface, and then we have this ball and lever. So, this is the axis, this is the angle inclination theta. Now, we always see the workpiece will be moving like this. So, when we insert the different workpieces, so this will be the movement of the lever, and we can also move the dial test indicator in this fashion. So, whatever be the movement of indicator or workpiece, we should see that this angle is always minimum, so that cosine error effect is minimized. Now, moving to the digital indicators. Now, this shows an indicator, and different functions are available like on off function and then hold function. So, and then the selection between the English system or metric system, all those things are possible, and then the data transfer is possible using RS-232C for transmitting the data to computer for statistical process control. And then we can see here, this is the dial indicator stand, and the digital indicator is fixed to the stand, and then we can keep the workpieces here for measurement purpose. So, you can see the stand is very robust. Now, what are the features of digital indicators? Now, we can set the tolerance limits using that tolerance option, and go and no go judgment is possible. That means, when we the digital indicator is used for checking the workpieces, if the dimension is within the limits, it will say workpiece can be accepted by way of displaying the green color. If the workpiece dimension is outside the limit, tolerance limit, it will that will be indicated by a red color by the indicator. Another important and very interesting feature is remote control via handheld controller. The dial indicator may be at any place, maybe 1 meter or 3 meter or 10 meter away. So, that can be controlled by using remote control. We need not have to go to near the indicator, and we need not have to physically touch the indicator for setting purpose. And RS-232C interface is possible. See, since remote control is possible, 0 setting and presetting without touching indicator is possible. See, normally what happens, if this remote control option is not there, for setting we have to go near the instrument and physically we have to touch the body of the indicator and we adjust the indicator. So, during that time the setting may change when we are doing measurements of very precise and maybe micron level measurements. In that case, that setting also we should maintain. So, if we physically touch the indicator, the setting may get disturbed. So, our measurement may be there may be some error in the measurement. Since this remote control is available, we can always use for very accurate and precise when precise measurement is required. And these digital indicators can be incorporated into measurement network. Maybe there are some 100, 200, thousands of instruments are there. All the data can be sent to the host computer for analysis purpose, and these instruments can be networked into such an arrangement, and they are available in various ranges like 0 to 25 and 0 to 50 millimeter. Longer ranges are also possible with resolution of 0.001 mm, 0.01 mm with an accuracy, measurement accuracy of 0.03 mm. Now, these are digital thickness gauges. So, you can see there is an anvil and spindle, and this will show the reading. We know this, there is no vernier, there is no dial. Directly it gives the digital display. To lift the plunger, and to insert the workpiece, we have the plunger lifting arrangement. We have to hold this instrument, and then using our thumb we can pull this so that plunger moves up, and then we can insert the workpiece here, and then we have to release this lever, and then the dial reading can be directly taken. And there are various kinds of spindles and anvils, interchangeable anvils and spindles are available for various applications. Now, the graduation it can be 0.01 mm or 0.001 mm, and range is 0 to 10 mm, 0 to 12 mm, they are available. And these two pictures show dial type sheet metal thickness gauge. Again we have a lever here, we have to hold this body in our hand, and then we have to pull this, and then we have to insert the workpiece here, and this will directly give the reading. So, in this case the graduation is 0.1 millimeter and range is 0 to 10 millimeter. Now, what are the various applications of thickness gauges? So, it can be used for paper thickness measurement. See, in that case we can use a very short range thickness gauges like 0 to 5 millimeter thickness or 0 to 2 such 0 to 2 millimeter thickness range, such narrow range gauges are available. So, you can also use thickness gauges for measuring convex lenses and concave lenses. In such cases interchangeable anvils and spindles will be of much use. For example, say we want to measure the convex lens like this. So, in that case we can use both flat anvil and flat spindle. But when we want to measure the concave lens, say we have a concave lens like this. In that case we cannot use the flat anvil and flat plunger. So, there will be error. So, spherical type or ball type plunger and ball type anvils are available. So, such things can be used. Also this can be used for tube thickness measurement. For example, so we have the flat plunger, and then we can use a ball type anvil like this, and then the tube can be inserted here. I am inserting the tube, and then we have to move the plunger down, and then this will make contact, and then we can directly take the reading. And then narrow groove depth measurement is also possible. Say we have a very narrow groove like this, say of 2 millimeter 2.5 millimeter groove. So, in such cases we have to use a blade type plunger and anvil. So, which will comfortably go into the narrow groove. So, blade type plunger and anvils, they are available with thickness of 0.75 millimeter, 1 millimeter, 1.5 millimeter like that. So, appropriate blades we have to select and can be used for thickness measurement. Now, what are the specifications of thickness gauges? They are available in various ranges like 0 to 12 millimeter range, 0 to 10 millimeter range, and then resolutions of 0.001 mm, 0.01 mm, and then they can offer the accuracy of plus or minus 3 microns, plus or minus 20 microns. So, depending upon our requirement, we can select the instrument and use it. And then now we will move to digital depth gauge. Now, digital depth gauges with very excellent features are available. Coolant proof digital depth gauges are available, which can be used in very harsh machine shop environment, and different ranges and different resolutions are possible, and they are fitted with battery, and battery life will be like 20,000 hours continuously we can use. And recently solar type depth gauges are also available, and so we have to put this moving rod, which this is the depth measuring rod. So this is the workpiece, and then we have to take this digital depth gauge and we have to keep like this. And then this rod will we have to make the rod to move in, and then that carbide tip will contact the bottom, and then this indicator will directly give the reading. And then extendable rods are also available depending upon the depth of hole or the height of the work pieces. We can select appropriate extension rods, and then we can fit them and we can use them. Now, various kinds of depth gauges, the digital depth gauges are available with a range of 0 to 150 millimeter, 0 to 200 millimeter, and 0 to 300 millimeter also available with resolution of 0.01 mm and accuracy of plus or minus 0.02 mm, plus or minus 0.03 mm, and they can offer a repeatability of 0.01 mm and repeatability of 0.01 mm. They have a very good accuracy of plus or minus 0.02 mm, and for this particular range the accuracy is plus or minus 0.03 mm. Now, depth gauge attachment for vernier, so some attachments are also available. Now, we can see that sketch of depth gauge attachment. Now, we can see here depth gauge ends, different kinds of ends are available. Now, this is a hook type end. This is the rod of the depth gauge, and it is shaped like this. Hook type shape is there. Now, say we have a hole of this shape in the workpiece. Now, I want to measure the total depth. So, that is possible even with ordinary dial depth gauge or vernier caliper, we can measure this. Now, I want to know this thickness. So, this is not possible with our ordinary depth gauges. So, there this hook type depth gauge will be of much use. Now, you can see here we have to move this depth gauge towards this end, and then we have to lift this end, so that this end comes in contact with the workpiece under surface, inside surface, and then we can directly read this depth D2. And sometimes we will be having a projection in the workpiece like this. I want to get this dimension D3. If it is outside surface, we can use the other instruments like vernier caliper or micrometer, but now this is inside. This projection is inside a deep hole. So, in such cases this hooked hook end will be of much use. You can see here, once we have to take reading here, this surface of the hook will be in contact with this surface, we have to take the reading, and then it is moved like this, then again we have to increase the depth, and then now this upper surface will come in contact with the bottom surface of that projection. So, again we have to take the reading, and then difference gives this thickness D3. So, like this we can have different kinds of ends depending upon the application, and then we can use. Now, for ordinary vernier caliper or dial type depth gauge, we can have attachment, depth gauge attachment for vernier caliper. Now, you can see here the vernier caliper can be inserted, there is a slot here or groove here. So, through that we can insert, and then there is a screw, we can clamp it, and then we can use that complete assembly for depth measurement purpose. So, by using this attachment to the caliper, we can comfortably measure the depths. And also the dial type depth gauges are available with the range of 0 to 300 millimeter and resolution of 0.05 millimeter. So, depending upon our requirement, we can select either vernier type depth gauge or dial type depth gauge or digital depth gauge. So, before we select the instrument, we should make a survey of the instruments, the economical aspect of that, and what are the various features, whether coolant proof type is required or not. So, such things we have to, what is the accuracy that is needed, what is the resolution that is needed, what kind of repeatability is expected. So, all such things we have to see before making a selection. Now, we will move to a special type of caliper. We have studied vernier caliper and different types of calipers, inside caliper like that. This is a very special universal caliper wherein we have the bar, okay, this is the main bar of the instrument, on which we have measuring heads. This is one anvil, and this is another, and this is the measuring head, and this is the second anvil. In the case of ordinary mechanical type vernier caliper, what happens is there is one fixed jaw and then another moving jaw, whereas here both these arms or jaws can be moved at a time. So, this can be moved in this fashion like this. So, this can be moved like this, and this can also be moved. Now, we can keep the workpiece between these two, and we can take the reading. Now, multiple dimension measurement with see all these anvils can, the set of anvils are available depending upon our application. We can change these anvils and we can use it. For example, for the measurement of thickness, for example, say we have a workpiece like this and we want to measure this thickness. So, in that case we can use two flat type anvils, and say we want a tube or a pipe, then one can be flat and one can be ball type or round disc type like this, disc type ends. So, when we have both disc type ends, so this can be used for measurement of thickness, and as well as for measurement of pipe also we can measure. This is the pipe and this can be moved and it will make contact here and thickness can be measured. And then the internal dimension measurement is also possible, and then center distance is the distance between two holes. So, that center distance can be measured, and then the distance from edge of the workpiece to the center of the hole. So, that is also possible. So, the anvil can be like a spherical anvil and another can be conical. like this. So, we have to fix this spherical type here and anvil type here, and then using this combination we can find the edge to center of hole distance. Similarly, if say we have 2 holes and we want the distance between this center and this center, in that case both conical type we should use. So, it will give directly the center distance. So, like this various kinds of measurements are possible, and they are available with a wide range of wide ranges like 0 to 150 millimeter, 0 to 300 millimeters with the resolution of 0.01, 0.001 with an accuracy of the 2 microns, 3 microns. So, depending upon our requirement we can select this type of instrument. All functions like hold function, on off function, and then conversion from inch to mm, selection of inch system and metric selection, and then the data transfer possibility like RS-232C port. So, all such things are available in this universal caliper. Now, we will conclude this session. In this session we studied about different kinds of dial indicators, digital dial indicators, then dial type dial indicators with varied ranges, varied resolutions, selectable resolutions, and then we studied about lever type dial indicator or dial test indicator. We also studied about thickness gauges and what are the features of thickness gauges, and then what are the various applications of dial indicators. We also discussed about universal caliper, what are the various features of universal caliper. So, with this we will conclude this session. Thank you.